All right, let's dive right into this explainer. Have you ever just looked up at the sky and wondered how on earth something so incredibly heavy just glides through the air like it's nothing? Well, today we're going to unlock that exact mystery, and we'll do it using a super simple, hands-on egg carton experiment to explore the physics of flight.
Here's our roadmap for today. First, gliders versus airplanes. Second, Bernoulli's principle explained. Third, riding thermals and updrafts. Fourth, the egg carton experiment itself. And finally, number 5, the science of the penny.
All right, Section 1, gliders versus airplanes.
So, a glider is actually totally different from a traditional airplane. Why? Because it doesn't have a power source. It literally relies entirely on gravity and just a highly efficient design to stay airborne and eventually glide back to Earth. And, fun fact here, even the space shuttle functioned as a massive glider during re-entry and landing. It only used its rocket engines for liftoff.
And here you can see a hang glider in action, which relies on the exact same basic principles as early aircraft. In fact, it functions just like the famous 17-foot gliders the Wright brothers used out at Kitty Hawk. Between 1900 and 1903, they ran a whole series of glider flights just to gain piloting experience and really to understand aerodynamic forces before they ever even tried adding an engine to the mix.
Moving on to Section 2, Bernoulli's principle explained. Now this right here is the absolute foundation of flight. It's called Bernoulli's principle. Because of a wing's curved shape, air flowing over the top has to travel faster, and that actually creates low pressure, which is a pulling force. Meanwhile, the air flowing underneath the wing creates high pressure, which creates a push. So you've got a push from the bottom and a pull from the top working together to overcome gravity and create lift. It's pretty amazing.
Next up, Section 3, riding thermals and updrafts.
Okay, I want you to hypothesize with me for a second. If gravity is always winning, constantly pulling a glider down, how do they stay aloft for hours? Or even large birds like hawks and owls, right? How do they manage to stay up in the sky so long without an engine?
Well, the secret is that pilots actively look for air that is rising faster than the glider is descending. They do this by utilizing updrafts. That's wind blowing at a hill or mountain that has to physically rise to climb over it, and they also look for thermals. Thermals are basically invisible pockets of rising hot air over dark land masses that absorb heat from the sun. So a glider is essentially catching a free ride on these naturally rising elevators of air.
All right, Section 4, the egg carton experiment. Let's put this into practice. To build our very own glider, you just need a few basic materials that you probably already have lying around the house. You'll need a 1-dozen-sized styrofoam egg carton lid, some scissors, a pen, a wing pattern, and a penny. Keep that penny handy, by the way, because it's going to be the star of the show in a minute.
Here's the step-by-step. Step 1, place your cutout wing pattern right inside that foam lid. Step 2, trace the pattern with your pen. And Step 3, just cut along the tracing on the foam lid. What's brilliant here is that the natural curve of the egg carton lid actually gives us the exact aerodynamic shape we need to capture Bernoulli's principle. Once you're done, your final cutout foam wing will look just like this, and you're ready for a test flight. I highly recommend giving it a gentle, flat toss forward. Don't chuck it too hard. Just toss it and observe what happens.
Which brings us to Section 5, the science of the penny. So, if you test the glider exactly as it is right now, you'll probably see it wildly loop, flip, or just straight up crash during the initial test flight. It is not going to fly well at all. And we have to ask ourselves, why? Why does that happen? What's our design missing?
This is where our lucky penny comes in. Try wedging that penny securely into the front indention of the foam glider, right up there in the nose. If it's a bit loose, you can totally use a tiny piece of tape, but doing this is going to completely alter its flight path.
And here is the science behind it. For aircrafts and other flying objects to actually fly, more weight has to be toward the front to help it stay stable or balanced in the air. That's absolutely crucial. Without that forward weight, the lift created by Bernoulli's principle just pushes the lightweight nose up into a crazy backflip. But with the penny in place, it counters the lift perfectly, keeping the glider stable so it can just sail smoothly through the air.
To wrap things up, I really challenge you to experiment further, just like early aviation pioneers did. What happens when you add more pennies? What if you test your glider in different outdoor environments, like over dark asphalt on a sunny day to see if you can catch a thermal? What else can you discover about these invisible forces holding aircraft up in the sky? Go test it out, stay curious, and I'll catch you on the next explainer.